In this video, I'll be covering sections 3.2 and 3.3, which deal with compound statements, connectives, and truth tables. So let's go ahead and get started. On number 1 here, we're going to discuss compound statements and connectives. Notice simple statements convey one idea with no connecting words. So some examples: you make lots of money, excuse me, you are happy, dogs like meat. Compound statements combine two or more simple statements using connectives. Connectives include such words as and, or, if then, and if and only if. So I've made a table here, and you can see the different statements and the symbols we used. So for example, on the first one here, you have P and Q, which is symbolized this way here. So I would read that P and Q. And this is called a conjunction. An or statement is called a disjunction. It's very similar to the and case. Notice the if-then statement. That's this one here. If P, then Q. Another way we often say that is P implies Q. And that's what we call a conditional statement. And the if and only if statement is biconditional. Basically, P implies Q and Q implies P. The implication is both ways. All right, so let's go ahead and do I'll do a problem here. Well, several problems. On example 1, it says let P and Q represent the following simple statements. So statement P is it is Friday, and statement Q is you are happy. So write each of the following in words. So I've given you the symbols, and then you've got to write the actual words. So on the first one here, this is statement P and Q. So we would say it is Friday and you are happy. Number 2 is similar. It's a disjunction or an or statement. This is P or Q. So it is Friday or you are happy. I'll do one more with you, and then I would encourage you to do the others and then check your work. On number 3, let's see, not P, so it is not Friday, and you are not happy. Okay, so go ahead and try 4 through 7, and then I would encourage you to check your answers on the video. Okay, so I'm going to go ahead and put up the answers here. So if it is Friday, then you are happy. That's number 4. On number 5, if you are not happy, then it is not Friday. Number 6, you are happy if and only if it is Friday. And then finally on number 7, it is Friday or you are not happy. All right, so let's move on to the next slide. So at the top here, I have a summary of symbolic logic statements. So these are all the ones that we've discussed. So I just want to point out a couple of things. On the conjunction, notice that we could also use the word but instead of and. So if we use the word but, it's another way to indicate a conjunction. So you want to watch out for that. On the conditional, notice other ways to say if P then Q would be P is sufficient for Q or Q is necessary for P. And then finally, and again, I want to remind you, we said P implies Q. That's another way we read a conditional statement. And then the biconditional, notice the if and only if statement can also be said as P is necessary and sufficient for Q. All right, so let's do a couple of examples. On example 2, it says let P and Q represent the following simple statements. So P is I am eating, Q, you are sleeping, R, Wesley is angry, and S, Wesley is hungry. Write the following compound statements in symbolic form. I am eating, but you are sleeping. Now remember, but is used in the same way that and is used. And so I am eating and you are sleeping. That would be P and Q. So go ahead and try B, and then I would encourage you to check your answer. So Wesley being hungry is necessary and sufficient for Wesley being angry. So that would be, the biconditional. So we would have S if and only if R. Okay, so let's go on to number 2. It says write each symbolic statement in words. So not P, that would mean I am not eating, and S, Wesley is hungry. So we would say I am not eating and Wesley is hungry. Again, if you haven't already tried B on your own, I'd encourage you to do that. So you should have gotten, let's see, R is Wesley is angry, and that would be an or symbol. And then we have not Q, which would be you are not sleeping. So we have Wesley is angry or you are not sleeping. All right, let's move on to the next page, the next slide. So we're going to talk about truth tables now for negation, conjunction, and disjunction. It says a statement has two possible truth values, true, T for true, F for false. We've talked about this before when we defined a statement. A statement is always either true or false, and so we call that truth or it being false a truth value. So a truth table is a table with a row for each possible set of truth values for the statements being considered. So let's look at negation. Now if we have some statement P, statement P is either true or false. Well, if P is true, then not P would have the opposite truth value and it would be false. And if statement P is false, then not P would have the opposite truth value, which would be true. And let me add one more in here. How about not P? So if we look at not P and we add another not to that, it's going to be the opposite. Not P will have the opposite truth value of not P. So instead of false, we would have true. So notice not P has the same truth value as P. And similarly, we'll get false in the case down below. All right, so let me give you an example here with a sentence or statement. So statement P is Mr. Smith is a math teacher. That would be me. Not P, Mr. Smith is not a math teacher. Not P, it is not the case that Mr. Smith is not a math teacher. Now that's a double negative, but it is equivalent to the original statement P. All right, let's move on to conjunction. The conjunction P and Q is true if and only if P and Q are both true. So when we do a truth table, we're going to set up, and this is for two statements, P and Q in this case, we're going to set up our truth table, or we're going to start it this way. So first of all, we're going to say P is true and Q is true. And then the second case, P is true and Q is false. So both of those are when P is true. Now we're going to move to the cases where P is false. So we could have false true, or we could have false false. So notice we have true true, true false, false true, and false false. Now you can remember this a number of ways. We're doing the true possibilities before the false possibilities, but there's also a pattern here. Notice you have on the P's true true, false false, and on Q you have true false, true false. So whatever you need to remember the way we set this up, I want to encourage you to make sure you're doing that correctly. They should be the table should be started this way by giving P and Q the truth values as I've indicated here. All right, so now we're ready to do P and Q. Now it says a conjunction's true only if P and Q are both true. So the first case is true true, so P and Q is going to be true. And now notice in the other three cases, so true false, they're not both true, so this is a false statement. False true, they're not both true, so this is a false statement. And the same thing's true for false false, so this is a false statement. So an and statement is only true if both statements are true. All right, so let's look at a couple examples. It says evaluate the truth of the following statements. Some teachers are good singers. Well, I would say that's true. Now, I may not be one of them, but I know that there are at least some teachers out there that are good singers, so that's a true statement. And all students at Brookhaven College are rich. Well, we definitely know that one's false. And so since this is an and statement and both statements are not true, we're looking at a false statement here. Number 2, spinach is good for you. Well, I've been told that for a long time, so we're going to assume that's true. And Kevin Durant plays for the Brooklyn Nets. Now, last time I heard, that's where he's at, so I'm going to assume that's also true. So we're assuming that's true. I think I did hear a rumor about him moving again. Anyway, all to say, Kevin Durant is a famous basketball player that used to play for the Golden State Warriors, and I think it was last year he moved over to the Brooklyn Nets. All to say, we have two true statements here. So we do have both statements true, which makes this and statement true. All right, let's move on to the next slide. Disjunction. The word or can be used, can be interpreted in two different ways. An inclusive or means either or both. An exclusive or means one or the other. So in our use of the English language, we will sometimes use one or the other, but in mathematics and in logic, we're going to be using the inclusive or, unless we're told otherwise. Okay, so here it says determine whether this statement is using an inclusive or an exclusive or. Number 1, I will buy a Porsche or a Maserati. Well, I'm probably buying one or the other, not both. In fact, I would be lucky to buy either one of these, as would most people. So this would definitely be the exclusive or. Number 2, an oil change is good for 5,000 miles or 3 months. Now notice you would want to get your oil changed either when you hit 5,000 miles or 3 months, or it is possible they could both occur at the same time. So this would actually be a case of an inclusive or. All right, so let's look at the table, truth value table, or truth table for a disjunction. The disjunction P or Q is true unless P and Q are both false. All right, so let's go ahead and you might try to see if you can put the truth values for P and Q incorrectly. So you should have said true, 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 false, false, true, false, false. Okay? So now notice it says the disjunction P or Q is true unless P and Q are both false. So normally an or statement is true. The only time it's not is when both statements are false. So we have true, true in the first case, so they're certainly not both false, so that would be a true statement. True, false, at least one of the statements are true, so the statement's going to be true. Same thing for false, true. Now notice in the last case, both statements are false, and so this time we would say the or statement is false. So let's make sure we have this down. With an and statement, they're usually false. The only time an and statement is true is when both statements are true. With an or statement, they're usually true unless both statements are false. All right, so let's look at a couple of examples down below. Evaluate the truth of the following statements. Some teachers are good singers. Well, that's true. Or all students at Brookhaven College are rich. Well, we've discussed this before. We know that's false. And so with an or statement, only one of them has to be true in order for the statement to be true, so this would be true. Number 2, spinach is bad for you. Well, that's false. And Kevin Durant plays for the Golden State Warriors. Well, I know that's not true. And so since both statements are false, this is a false statement. All right, let's move on to the next slide. All right, so now we're going to be constructing truth tables, and this takes a little bit of practice. I'm going to do number 1 with you, and then I want you to try number 2, and then I'll do the same thing with 3 and 4. So go ahead and see if you can put in the correct truth and false letters for P and Q. All right, so you should have said true, 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 false, false, true, and false, false. So now with P or Q, we know that that's usually true. The only time it won't be true is if both statements are false. So true, true, that's actually, so notice false, false is what we have at the end there. And so that's the only statement that's going to be false. Notice in the other 3 cases, at least one of the statements are true. And so these are all true. Now notice what I did. You've got to build this up. You start by putting in P and Q, and then now we need to put in or figure out what the truth value is for P or Q, and that's what's inside the parentheses. And then the last thing we'll do is apply the not. And so now not P or Q, well, these each of these are going to have the opposite value of what we got in this column. So it's going to be false, 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 and true. All right, so go ahead and try number 2, and then watch the video to see how you did. All right, so you should have said true, 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 false, false, true, and false, false. Now, not P is going to have the opposite truth value of what's in this column, so we're going to have false, false, true, true. And not Q will have the opposite truth values of what's in this column, the Q column, so it'll be false, true, false, true. So now notice we're going to be doing an and statement with not P. Actually, let me do it this way, with these 2 here. So remember, an and statement is only true if both statements are true. So that occurs here. And so we'll put a true there. Now in the other 3 cases, both statements are not true, and so these will be false. All right, so let's move on Oh, let's see. To number 3. It says construct the truth table for, let's see, in parentheses, not P or Q, and then and not Q. So I'm going to go ahead and make a little table here. So first of all, we have two different letters which represent statements P and Q, so we'll start with those. And again, as always, we're going to put in our truth values for P and Q. We have our 4 cases: true, 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 false, false, true, false, false. Now notice we're going to need not P at some point, and we're also going to be needing not Q. So again, we're building or constructing a table here. We got to do it piece by piece. So not P, well, these are going to have the opposite truth values of what P had. So we're going to have false, false, true, true. And then for not Q, well, those are going to have the opposite truth values of Q. So it'll be false, true, false, true. So let's see, I think what we want to do next is what's in the parentheses here, not P or Q. And so we're going to use these 2 columns here with an or statement. Now remember, an or statement is true usually unless both statements are false. So that happens here, and so that's the one that's going to be false. Now on all the other ones, there's at least one true statement, and so those will be true statements. So finally, we're ready to do the whole statement that we were given to start with. So now we're going to look at not P or Q and not Q. So that's these 2 statements here. Now remember, with an and statement, these are usually false. The only time an and statement is true is if both statements are true, and so that would be this case here. Now in the other 3 cases, both statements are not true, so these would be false statements. All right, so let's move on to the next problem, and I would like you to go ahead and try that one, and then I will put up the solution. All right, so let me go ahead and make my diagram or chart. Let's put in our P's and Q's and our truth values. Now let's go ahead, and we do need not P and we also need not Q, so let's put in not P. And not P will have the opposite truth values of what P had. So that would be false, false, true, true. And let's see, not Q. Well, the truth values will be the opposite of what they are for Q. So false, true, false, true. So now notice what's in parentheses here. That's what we're going to want to do next. P and not Q. And so we're going to be working with these 2 columns here. Now again, this is an and statement, and we know and statements are usually false. They're only true when both statements are true, so that would be this case here. So that's where we're true. But in the other cases, we have true, false, 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 and false, true. And so we don't have both statements true in any of those cases, so we're going to be false there. So finally, we're ready to put the whole statement together, not P or the quantity P and not Q. So now we have an or statement with these 2 columns here. Now we know an or statement is only, let's see, usually it is true unless both statements are false. Well, these are both false, so this will be the only time when both statements are false. and so this is a false statement. In all the other three cases, at least one of the statements is true, which makes the whole statement true. All right. One of the things I would encourage you to do is maybe go back and read the sentence examples that we did and see if it makes sense to you that with an and statement, it's only true if both statements are true. And when you read an or statement, it's only false when both statements are false. If you can make some sense out of that by reading them, then it'll make it easier to remember how to do the problems. And that's it for this video.